This is the Chapter 7 test review. So Chapter 7 is all about rational expressions and rational equations, how to simplify and then solve, right? So let's go ahead and jump in. We've got 24 problems, yep. So we're just going to go through them one at a time, and feel free to go through your review with me. These problems match your exact problems in your review. Here we go. Problem number 1, simplify this expression x squared plus 2x over x squared minus x. Now, when you have a rational expression, you want to factor what you can out of the top and factor what you can out of the bottom. So let's see what results after we factor. I see a GCF on the top. The GCF is x, and when I factor out an x, I'm left with an x plus 2. And in the bottom, I see a GCF of x. And so when I factor out that x, I'm left with an x minus 1. Great, so I have factored both the top and the bottom of this expression. Both of them had a GCF. Now at this point, I can cancel. So I see a common factor on top and bottom of x. And so my remaining factors that don't cancel are x plus 2 on the top and x minus 1 on the bottom. And this is my final result. Great. Let's move on to problem 2. Simplify the function formula and, if applicable, write the restricted domain. Great. So here we have another rational expression that this function is defined as. And so I will factor the top and bottom if possible. So looking at the top, y plus 8, well, it doesn't factor any further. And the bottom is a trinomial that factors to, looks like y minus 8, no, y plus 8 times y minus 3. There we go. So I was looking for two numbers that multiply to make negative 24, but sum to make positive 5, and those two numbers are 8 and negative 3. At this point, I notice there's a common factor on top and bottom. The y plus 8 factor will cancel on top and bottom. When everything cancels on top or bottom, there's an invisible factor of 1 that appears. And so my reduced function, r of y, it's equal to 1 over y minus 3. So I had the invisible factor of 1 that appeared because everything canceled on top, and then the y minus 3 factor on bottom. Great. Now, what is the restricted domain? Well, the restricted domain is when I take the denominator and set it equal to 0, right? So we saw that this factors to y plus 8 times y minus 3, that denominator. And if it's set equal to 0, there are values for y which cause the denominator to be 0, like negative 8 and positive 3 for each y respectively. Okay, so y, in this case, cannot equal negative 8 or positive 3, because it would cause the denominator of this fraction to be 0. So that is the domain restriction, right? Two things cause the denominator to become 0. Moving on, problem 3, simplify this rational expression. X squared plus 7x plus 12 divided by x squared minus 9. So to simplify the rational expression, let's factor. So first thing is to factor the top and the bottom. And x squared plus 7x plus 12, well, I can write that as x plus 4 times x plus 3. Once again, I'm looking for two numbers that multiply to make positive 12, and that's 4 and 3. Right? 4 times 3 is 12. And they also sum to make positive 7. 4 plus 3 is 7. So there you go, we factored correctly. And now I look at the bottom and I notice the difference of squares. X squared minus 9 is the difference of squares. It factors to x plus 3 times x minus 3. All right, we've completed the factoring, and now we look for common factors that cancel on top and bottom. So I notice this x plus 3 cancels this x plus 3, and the resulting factors are x plus 4 on top and x minus 3 on the bottom. Done. All right, so we're ready to move forward. We have answered problem number 3. Moving on to problem number 4. we're going to multiply two rational expressions together. So I have this rational expression times this rational expression. And to do it, we're going to factor everything we can. Okay, so I'm going to factor the top left, then the bottom left, then the top right, and then the bottom right. So looking at the top left, x squared plus 6x plus 9, factoring that, I notice that is a perfect square trinomial. It's x plus 3 times itself, right? X plus 3 times x plus 3 will produce that trinomial. Now look at the bottom left. So the bottom left would be x minus 5 times x plus 3. Great, top right is the difference of squares. Yeah, so I'm going to factor the difference of squares by putting x and 5 in two binomials and then put opposite signs because they're conjugates. They are two conjugates that multiply together to make the difference of squares. And lastly, I look at the bottom right and I factor that trinomial. And it looks like it's going to be x plus 5 times x minus 3. Now that we've factored everything and there's multiplication between these two fractions, I can cancel factors across the two denominators and numerators. So if I see any common factor, I can cancel them. So like this x minus 5 and x minus 5 will cancel. X plus 3 cancels x plus 3. And x plus 5 cancels x plus 5. So we saw all the common factors that canceled, and now I'm going to write my answer as the remaining numerator factor, which is just x plus 3, divided by the denominator's remaining factor of x minus 3. Yeah, so I just had this x plus 3 divided by x minus 3. This is my final result. That's how I'll report my answer. Moving forward to problem number 5. So perform the indicated operation and simplify if possible. Assume all canceled factors are not 0. When I see this, I see the multiplication of two rational expressions and then the division of this rational expression afterwards. Whenever we encounter division of rational expressions, we want to switch it to multiplication by taking the reciprocal of the fraction after the division symbol. So I'm going to do that, and I'm also going to write everything as prime factors as I go. Right, so 48, it breaks down into, 2 times 2 times 2 times 2 times 3. That's what 48 breaks down into all its prime pieces multiplied together. Okay, so I just am deciding to expand everything, so you see one approach that you could take to simplify this all. And then in the denominator, see, I have s squared, and so I'm going to write s times s. Great. Moving forward, now I'm moving to that second fraction, and I'm going to break it into its pieces. Like I see 3s squared t squared, which is 3 times s times t times t. Right? So you could break it down all the way into all those pieces. And that's divided by s cubed. So I have s times s times s. Now this is where I'm going to switch division to multiplication and then apply the reciprocal of the third fraction. Right? So I'm going to take the reciprocal of this. So s to the fourth I'll put on top as s times s times s times s. And 12s cubed is 2 times 2 times 3 times s times s times s. Now you'll wonder, why have I done it this way? And you don't have to expand it all the way like I have. But because it helps me see all the factors really easily. Because now I know that this 2 can cancel that 2, this 2 cancels this 2, this 3 can cancel this 3. Now let's focus on s's. Like this s cancels this s, this one cancels this one and this one, this one and this one, this one and this one, this one and this one. So I was able to cancel all of those things, and I can see them clearly when I lay it out in the prime factorization. Okay, now that I've canceled everything possible, I'm going to write my final result. And that final result is going to have 2 times 2 times 3 in the numerator. I'll multiply those back together. 2 times 2 times 3 is 12. Great. And now I have a t and a t on top. So t times t is t squared. And then what's remaining on the bottom is an s times an s. So I get an s squared on the bottom. And that's my final result that I'll report. 12t squared divided by s squared. All right, moving forward into problem number 6. It says perform the indicated operation. That operation is division, right? Simplify if possible. And so I'm going to keep it, switch it, and flip it, right? This is a rational expression divided by a rational expression. Let's keep, switch, flip. While I keep, switch, flip, I'm also going to factor. Great, so here's my setup. And I look at the first expression, 3t minus 9, and I say, well, I can factor out the GCF of 3, and I'm left with a t minus 3. In the bottom left, 2t minus 10, I can factor out the GCF of 2, and I'm left with a t minus 5. Great. So I kept this stuff the same, but I factored it. Now I switched division to multiplication, and now I'm going to take the reciprocal of this stuff and factor at the same time. So this stuff on the bottom, I'm going to write it on the top, factored. And t squared minus 10t plus 25, well, think of two numbers that multiply to 25 but sum to negative 10. And pretty quickly, I discovered that's t minus 5 times t minus 5. And now the top, I'm going to write on the bottom, right? And this top trinomial factors into t minus 3 times t minus 3, right? So these happen to be perfect square trinomials here and here because they factor to the same piece times itself, the same piece times itself. At this point, now that I'm done with the keep, switch, flip, and factoring, I'm going to get out my canceling pencil because this t minus 3 factor can cancel that t minus 3 factor. This t minus 5 factor cancels that t minus 5 factor. And it looks like I have my final result in front of me. The factors of the numerator that are remaining are 3 and t minus 5, so I multiply them together. And on the bottom, 2 and t minus 3 are the remaining factors. And I'm done. Problem number 7. Simplify this expression and give your answer in the form of f of x divided by g of x. And so you'll see this is a rational expression divided by a rational expression. So we're going to keep, switch, flip. And while we do that, we'll factor as much as we can. Okay, so I'm going to write the setup for this. I've got a fraction times a fraction. Okay, and I'm going to factor this top left first. All right. So the factoring of this top left stuff, you know, it's not the easiest trinomial to factor. We've talked about it in the past. This has an a value of 2, and the b and c values are not multiples of 2. So we're going to have to think about this with a little trial and error, or you could use the AC method. So thinking about it for a second, I get a 2x and a 1x, right? 2x and a 1x, because those are the values that will multiply to make 2x squared. And then I need the outer and inner terms to sum to make 9x. And so if I do a plus 4 here and a plus 1 here, that'll do the trick. This will give me what I want. So there's the factoring of the top left. Let's look at the bottom left. And I look at it and I say, well, if I do an x plus 3 times an x minus 1, that'll do the trick. Okay, looking at now the top left, we're going to factor it in the top right, we're going to factor it in the bottom right. Yeah? So we're doing a keep. We're switching division to multiplication and taking the reciprocal of this fraction. Okay, so this top stuff I'm going to write now factored in the bottom. And two numbers that multiply to 16 but sum to 8 would be 4 and 4. So I have x plus 4 times x plus 4. This was a perfect square trinomial. And now looking at the one on the bottom right, I'm going to factor it in the top. And once again, this is a trinomial with an a value greater than 1. And thinking about it for a second, I would need to have negative 1s here and here. Great, so I factored everything. Please work on your factoring skills. Make sure you're up to par as you get ready for this test. Now that I have factored everything, I'm going to cancel any common factors. For example, I notice x minus 1 on top and bottom, and an x plus 4 also on top and bottom. And so my resulting numerators values are 2x plus 1 and 2x minus 1. These are the factors of the numerator that remain. I'm just going to multiply them together. And that is the answer for what f of x is. It's the top part of the answer, right? The top piece. And then the answer for the bottom part is the remaining factors on bottom, which are x plus 3 times x plus 4. And we're done. Great. These are my solutions. We're ready to move on. Problem number 8. And it says simplify the expression. Give your answer in the form of f of x divided by g of x. And we see that we have addition of rational expressions. And we also see that the denominator is the same, which is great. Okay, so first look at the denominators, see a comparison of them. And if they're the same, then we can add these two fractions together right away with the common denominator of x minus 1. And what we need to do is look at the numerators and clean up like terms. Simplify by combining like terms, like this 2x can be added with this negative x. 2x plus negative x is just x. And then this negative 4 can be added with positive 4, the constant terms added together. And negative 4 plus 4 is 0. So I have this plus 0 right here. But of course, 0, when you add it, it can be made invisible, right? So I'm just going to take away that plus 0. And then that x is all that remains in my numerator. So my final answer, for the top of this rational expression that results is x. So I write x for the top function. And then x minus 1 for the denominator's function, right? So x is this f of x stuff. X minus 1 is this g of x stuff. And we're ready to move forward to problem number 9. So we saw just now that it's quite easy when your denominators are the same to add or subtract fractions. Now, let's practice finding a least common denominator to help us prepare for when we don't have the same denominator. Great. So what is the least common denominator of these rational expressions? And so we only have to look at the denominators. Don't pay attention to the numerators at all. All right? And so the least common denominator for this situation is, well, look at the coefficients 28 and 4, and you're finding the least common denominator, the least common multiple, which is 28. Okay, so when comparing 28 and 4, 28 is a multiple of 4. It's the least common multiple of those denominators. But now we have the variables as well to consider. And so we're going to have a b to the 9th, okay, as the least common denominator. This one has b to the 4th. This one has b to the 9th. Okay, the least common denominator would be the larger of the two. Okay, great. So that's the LCD. And, one of the denominators was the LCD. Look at that. Okay, so this denominator was the least common denominator because it's a multiple of these values to make this. Let's look at this next one. Whenever you can factor, go ahead and factor. For example, 5b minus 5, I notice I can turn that into 5 times b minus 1. And 3b minus 9, I can turn that into 3 times b minus 3 when I factor out the GCF, right? So here I factored out a GCF of 5. Here I factored out a GCF of 3. Now, what is the LCD? Well, it's going to be all of the factors multiplied together that make those two fraction pieces. So I would take the 5 and multiply it with the 3, multiply that with the b minus 1, and multiply that with the b minus 3. These are all of the factors, okay, multiplied together. If you want to, you could turn this 5 times 3 back into 15, right? So you could turn this 5 times 3 into 15. There you go. Let's move forward, and we're going to find a least common denominator again of these rational expressions. And now we're going to have some, trinomials in the denominators. Now, please remember, when we're finding LCDs, we don't even look at the numerators. Don't even look at these. They will make no impact on what the LCD is. Okay, so here I go. I'm going to factor this trinomial, and I notice that it's x plus 7 times x plus 7. Great. So I factor that first trinomial. Let's factor the second trinomial, and I've got x plus 7 times x plus 2. Great. All right, so what is the LCD of these two denominators? The LCD, if you have any repeated factors, you have to apply them twice for the LCD. So I see an x plus 7, and it's multiplied with another x plus 7 in the same denominator. Okay, so I need those two x plus 7s in there. Okay, now this one already has an x plus 7, so that's part of the current LCD, but the LCD doesn't have this x plus 2, so I need to include it as a factor. Right, so this is the LCD, x plus 7 times x plus 7 times x plus 2. Let's look at this third option where we'll compare three denominators. Okay, so ignore the numerators. We're only looking at the denominators, and we're finding all of the factors possible. So when I look at x squared minus 4, my brain tells me that's the difference of squares, and so I factor it into x plus 2 times x minus 2. Great. When I see 6 minus 3x, I say that's the opposite of 3x minus 6, and so I factor out a negative. But I also have a GCF of 3, okay? And then I can swap my terms so they look like x minus 2. Now, if you had to convince yourself that this was correct, you could distribute the negative 3 back in your mind and say, does that give me what I started with? Well, I get a negative 3x and then a positive 6. So yes, that would do the trick, okay? Now, the last denominator is just x. It's just x all by itself. Great, so here are the factors of the denominators. So the least common denominator of these three fractions, it would be x plus 2 times x minus 2, and then I have a multiplication of negative 3 and also multiplication of x. Okay, so I've got that negative 3 factor multiplying with the factor x, which is multiplying with x plus 2, which is multiplying with x minus 2, which happen to be in these two separate denominators right there. Great, so we have found the LCD. Why do we work on finding the LCD, the least common denominator, so that we can use it to help us simplify expressions, getting a common denominator, and also to, when we're solving rational equations, to clear fractions. If we multiply everything by an LCD, it will clear fractions in an equation, which is coming up at the end of this review. Great, so let's move on to problem number 11. Perform the indicated operations. Express your answer in reduced form. It says 6y over y minus 9 plus 3 over 9 minus y. And I notice that my denominators are opposites. Opposites are when you take the two values and you switch their locations, right? Y minus 9 is not the same thing as 9 minus y. So subtraction is not commutative. So what you do is you factor a negative 1 out of the one that looks backwards. So I'm going to take 9 minus y and turn it into y minus 9 by factoring out a negative 1. Okay, you can always do this with opposites. So now I've made y minus 9 look like y minus 9. There you go. But because I factored out a negative 1, it flips the sign that is in the middle. Okay, so this plus, it is now a minus sign. Okay, so I'm going to just ignore the plus. I'm going to make it a minus because I factored out that negative 1. Now I've got the exact same denominators, and I can proceed forward to combine these two fractions into one fraction with the common denominator of y minus 9, right? Y minus 9 is the common denominator now, and I take 6y minus 3, and I make that my numerator. If you can factor further, try factoring further so you can see if anything cancels. Like 6y minus 3 has a GCF of 3, and I'm left with y minus 9, y minus 1. Okay, and that's divided by the y minus 9. There are no common factors on top and bottom. This is my final result. I have factored completely. Problem number 12, simplify this expression, give your answer in the form of f of x divided by g of x. And it says 1 over x plus 5 minus 1 over x plus 7. So these are not the same denominator. We do not have a common denominator. And so we have to ask ourselves, what is the LCD? The LCD is x plus 5 times x plus 7. So multiply the two denominators together. And so that's the LCD, right? So I'll write that on the side. The LCD, it's x plus 5 times x plus 7. Great. So I want both of my denominators to become the LCD. So I take the x plus 5, and it's missing the x plus 7 factor. So I multiply on the x plus 7 factor on top and bottom of the first fraction. And now I look at the second denominator, the x plus 7 denominator, and it's missing an x plus 5. That's what it's missing for its common denominator, so I multiply x plus 5 on top and bottom. And now I have the same denominator. Right? It's the x plus 7 times x plus 5 denominator. Okay, so my LCD is my new denominator for the combined fractions. Now I look at the numerators. By the way, with the denominator, you can just keep it like this. You don't have to FOIL it. You can keep it factored as you proceed. And the numerator needs to get cleaned up. So I'm going to distribute this 1 into both these terms of the binomial. 1 times x is x, and 1 times 7 is positive 7. Okay, now I move on to this next numerator piece. And you see this negative sign? It has to distribute into both of those terms. So whenever you have subtraction of two fractions, that minus sign applies to everything. This isn't just multiplying in 1 times x and 1 times 5. This is negative 1 times x and negative 1 times 5. That's why I'm writing negative x minus 5 right here. Great. So we've started to distribute stuff and clean up the numerator. In fact, this positive x cancels this negative x. They are the same value, opposite sign, right? X minus x cancels. And 7 minus 5 is 2. All right, so I got a 2 in my numerator, and I still have that x plus 7 times x plus 5 denominator that I don't touch. I keep my denominator factored, and I don't play with it. That's the answer. Great. So my fraction is 2 over x plus 7 times x plus 5. I have to report my answer in terms of a numerator as f of x. Well, my numerator is 2. And g of x, my denominator, is x plus 7 times x plus 5. Okay? Awesome. Moving forward into problem number 13. Perform the indicated operation and simplify if possible. Assume any factors you cancel are not 0. I have this fraction minus this fraction plus this fraction, and they don't have the same denominators, so I'm going to make them have the same denominators. All right? First, factor all the denominators in the scenario. So x squared minus 81 is the difference of squares, which factors to x plus 9 to x times x minus 9. Right? So I just factored the difference of squares right there. There it is. Now this bottom trinomial here, it factors, it looks like a perfect square trinomial. It factors to x plus 9 times x plus 9. And then this denominator, the third one, well, it doesn't factor any further. It's just x minus 9. Great. So at this point, we need to find an LCD, right? So maybe on the side we write what the LCD is. And looking at it, I would say the LCD is going to be, well, this denominator has two x plus 9s. So I've got to include x plus 9 twice because that single denominator had two of them, right? And then, well, the only other factor I see is x minus 9. It's in this denominator once and in this denominator once. So I just need to write it once in the LCD. There we go. So being very specific with you guys, the LCD of these three denominators is x plus 9 times x plus 9 times x minus 9. And so I'm going to write everything out with that common denominator, right? So I'll show you my resulting fraction. I'm going to turn three fractions into only one, and it will have the denominator of x plus 9 times x plus 9 times x minus 9, which is the LCD. Great. Now, this first fraction, this first one, it's missing an x plus 9 factor. So I'm going to multiply an x plus 9 factor on top and bottom to make that work. This second fraction, it's missing an x minus 9 factor. That's what it's missing. So I'm going to multiply on an x minus 9 factor on bottom and top. And lastly, this third fraction, it's missing, well, it's got the x minus 9 factor, but it's missing the x plus 9 factor twice, right? So I'm going to be multiplying on an x plus 9 times an x plus 9 on top and bottom of this fraction. Great. So this is how I've made all the denominators the same. Look, same, same, same. They have all three of the same factors. That's my new denominator when I combine all these fractions together. Now I don't need to worry about the denominators anymore. I'm going to focus on the numerators. And so I'm starting with the first fraction, and I'm going to distribute this 9 into both these terms, x plus 9. And so I get 9x plus 81. Great. Moving on to the second fraction, I see this minus sign right here. And that minus sign will distribute with the x into both of these terms, right? So I'm not just distributing x into this, I'm distributing negative x into x minus 9. And so now you'll understand why I'm writing negative x squared, because negative x times x is negative x squared. And negative x times negative 9 is positive 9x. Great. I've distributed negative x into x minus 9, and I got this stuff. Moving on, I see addition, which means I don't have to worry about distributing a negative into stuff. And I have this 1 times x plus 9 times x plus 9. So, 1 times anything is just that thing. So ignore the 1 and FOIL x plus 9 times itself, right? FOILing, you would get x times x, which is x squared. And then x times 9 and another x times 9, which gives you 9x plus 9x, 18x. So the outer and inner terms of FOILing add together to make 18x. And the last terms are 9 times 9, which gives us 81. It's positive. Great. We've now made it to this point, and it's time to simplify the numerator as far as possible. So let's clean up the numerator. For example, I see, and you'll have to forgive me, somehow I didn't get that squared in there, but that's x squared, right? Because I was multiplying x times x to get x squared here. Good. Everything's good now. Negative x squared and positive x squared, they cancel each other. And then looking at the remaining pieces, I've got a 9x plus a 9x plus an 18x. These linear terms will add together to make a 36x. So I'm adding them together, making 36x. Great. And then this constant 81 plus the constant 81, That adds together to make 162. My denominator is still the x plus 9 times x plus 9 times x minus 9. Okay, and you would ask, well, are we done? If we can't factor the numerator, we're done. Let's look. Can we factor this numerator? 36x plus 162. It looks like they're both multiples of 12. Yeah, so are they both multiples of 12? Let me do a little check really fast here. So if you ever have any questions about it, you could take those values and divide them. Trying to find the GCF. Oh, it looks like they're both divisible by 18. All right, so I'm going to factor an 18 out of both of these, right? And I'm left with a 2x plus 9, like this. Okay, so 36x plus 162, it factors to 18 times 2x plus 9. So what I'm going to do is I'm going to just replace that with the 18 times 2x plus 9. Why am I doing this? Because I'm trying to see if anything will cancel. And it looks like all of the factors that are in this expression are distinct. They are different from each other, right? Like this 2x plus 9 is not the same thing as x plus 9, right? I can't cancel this with this or this. Okay, so I'm stuck. This is my final answer that I'm going to report. That's as far as I could simplify. Problem 14. It says simplify the expression. Give your answer in the form of f of x divided by g of x. Okay, and I've got the addition of two rational expressions, right? I'm adding two rational expressions, and I see that this second denominator is factorable. So I'm going to factor out the GCF of x, and I'm left with an x plus 1. Great. I need my denominators to be the same, so I'm going to find an LCD. Well, my LCD, it's going to be, and by the way, this x squared is x times x. That might help you. Okay, my LCD is going to be x squared times x plus 1. That's my LCD. Now, what do I have to include with some of these things to make the LCD work? Okay, so looking at the first denominator here, this x times x is x squared, and it needs to be multiplied by an x plus 1 factor, right? So I'm going to multiply x plus 1 on bottom and on top of that fraction. And then to make the second denominator become the LCD, I need to multiply by x on top and bottom. Okay, so I'm multiplying x on top and bottom because x times x is what will give me that x squared. Anyway, I have now made the denominators the same, and so I can write my answer with a common denominator of x squared times x plus 1. My numerator, let's clean that up. I'm going to distribute this 1 into both of these terms. 1 times x is x. 1 times 1 is 1. So I get an x plus 1 there. Now I see this plus sign. So I'm adding 4 times x, right? Add 4x. And now I simplify the numerator even further by combining like terms, like 1x plus 4x, that's 5x. And I still have this plus 1. And that's divided by the same denominator that, was the LCD stuff. And there's my final result. It can't be simplified any further. Okay, so my answer for the function f of x, well, I will write 5x plus 1. And my answer for g of x, it's x squared times x plus 1. That's the final result. Can't be simplified any further. Let's move forward. And we're now looking at problem number 15. It says perform the indicated operation and simplify if possible. Assume any factors you cancel are not 0. I see a fraction divided by a fraction, so immediately I'm led to keep it, switch it, flip it. So I keep the first fraction the same. I switch division to multiplication, and I take the reciprocal of the second fraction, like that. Great. Now we can see if the fraction is reducible across the multiplication symbol. Like I noticed 32 over 8, that's a fraction that reduces, right? Because 32 is 4 times 8, so I can say that this reduces to 4 over 1. 32 over 8 is 4 over 1. Next, I see a factor of x that cancels on top and bottom, so that x just cancels completely. And now I look at 49 over 7, and I say, well, 49 is a multiple of 7. It's 7 times 7. So I can reduce 49 over 7 into 7 over 1. Okay, so all of this really simplified to 4 over 1 times 7 over 1. And 4 times 7, remember when you multiply two fractions together, just multiply the numerators. 4 times 7, that's 28. And that's divided by 1 times 1, which is 1. And when I divide by 1, that's invisible, right? I can make it invisible. So I report my final answer as 28. Problem 16. So not only can we multiply, subtract, add, and divide, right? Multiply, divide, add, and subtract rational expressions. We can simplify complex rational expressions. That's when we have rational expressions, right, on top and bottom of a rational expression. Rational expressions inside of rational expressions. And we learned a hard way and an easy way to get this done. And so we started using the easy way in our lessons. Here's the easy way to get it done. Multiply everything by the LCD of all of the denominators, right? So looking at 1, 2, 3, 4 denominators, what is the LCD? And I noticed that this x plus 2 factor is repeated twice, so I only include it in the LCD once. Yeah, so my LCD that I'm going to multiply the top and bottom by are x plus 1 times x plus 2 times x plus 3. Okay, and I'm multiplying the LCD on top and on bottom. There you go. And now I'm distributing the LCD into the first fraction on top and the second fraction on top, and then the first fraction and the second fraction on bottom. Okay, and now I'm going to write the result of multiplying in the LCD. Now really quickly, as you multiply the LCD into this first fraction, the x plus 1 factor will cancel this x plus 1 factor that I'm distributing in, right? So this x plus 1, I'll show you explicitly, cancels this x plus 1 as I multiply in the LCD to that term. And so this 1 will be multiplied with the x plus 2 times x plus 3, okay? That's why I'm writing x plus 2 times x plus 3 for my first result. Great. Now I've got a plus sign right here, and so I'm going to put the plus sign there. Now as I multiply the LCD into the second fraction, this x plus 2 denominator will cancel the x plus 2 factor that I'm multiplying in, x plus 2 and x plus 2, you see? And so I'm multiplying this 1 by the remaining factors of x plus 1 and x plus 3. That's what's happening. And 1 times those things are just those things. So I get x plus 1 times x plus 3. Moving on to the bottom. So this bottom piece, when I multiply in the LCD, the x plus 2 cancels with this x plus 2 factor. And so this 1 is multiplied with x plus 1 times x plus 3. All right, now I've got a plus sign right there, so I put it. And lastly, this x plus 3 denominator will cancel this x plus 3 factor, and this 1 is multiplied with x plus 1 times x plus 2. like this. Great. This is our resulting fraction, and we have gotten rid of the fractions of the numerator to get this result and the fractions of the denominator to get this result. Now, let's practice your foiling skills. You have to FOIL 4 times. First, outer, inner, last multiplication. Let me show you. You're going to FOIL this, and FOIL this, FOIL this, and FOIL this, right? So x plus 2 times x plus 3 FOILs to x squared plus 5x plus 6, right? Combining my outer and inner terms to make 5x. Now I have plus x squared plus 4x plus 3. I FOILed the top right stuff. Now moving on to the bottom left stuff, x plus 1 times x plus 3 FOILs to x squared plus 4x plus 3. You'll notice that was the exact same thing that we just got up here, right? Because it was the same factors multiplied together. And then I'm adding the FOILing of x plus 1 times x plus 2, which is x squared plus 3x plus 2. Lastly, I'm combining like terms of the numerator. So with the numerator, I have x squared plus x squared, which gives me a 2x squared. And the linear terms are 5x plus 4x, which gives me a positive 9x. And the constant terms are 6 plus 3, which gives me a positive 9. The bottom, x squared plus x squared gives me 2x squared. And linear terms, 4x and 3x gives me a positive 7x. And constant terms, 3 plus 2, that gives me a 5. Great. This is how I'll report my answer because these trinomials that I just got aren't factorable. I can't factor them. They're prime. The top trinomial is prime. The bottom is prime. Let's move on. And let's simplify this complex rational expression right here, right? So I've got 2 minus 5 over c divided by c plus 1 over 6c. And my goal is to find the LCD of all the denominators. So this 2, I can write it as 2 over 1. That way I can see my denominators are 1, c, and 6c. And the LCD of these denominators is 6c. That is the LCD. So I'm going to multiply the top by 6c and the bottom by 6c. And I'm going to distribute that 6c into all the terms. Great. Let's see what results. So 6c divided by 1 is still 6c, and multiply that by 2, 12c. So my first term that I get is 12c up here in the numerator. Now, if I take 6c and I multiply it into 5 divided by c, the c factors cancel, and 6 times 5 is 30. So I have the minus sign between, but I get a minus 30. Yes, minus, and then 6 times 5 is 30, and the c's have canceled. Now looking at my denominator, 6c cancels the denominator of 6c, right? 6c divided by 6c is 1, and 1 times c plus 1 is c plus 1. There you have it. Now let's see, can I factor the numerator? We always want to factor as far as possible to see if anything cancels. And I noticed that 12 and 30 they have a GCF of 6. And so I'm left with a 2c minus 5 in my numerator. I've got the c plus 1 factor in the denominator. There are no factors that cancel. This is my final result. Problem 18. Perform the indicated operation and simplify if possible. Assume any factors you cancel are not 0. All right. To clean this up, this is a rational, a complex rational expression. But this negative 1 power, you will recall, we talked about our exponent rules a couple chapters ago. But we really, tried to get you to learn them. And so we're going to rewrite all of this using our exponent rules. Negative 1 power. If you want to make any power that's negative become positive, we take the reciprocal of the base that the negative power was raised to. So when I see z to the negative 1 power, I turn it into 1 over z to the positive 1 power. Right? So I can make a negative exponent become positive if I take its reciprocal. Good. So there you go. And z to the first, I'll just write it as z. So this z to the negative 1 power becomes 1 over z to the positive 1 power. Now I have a plus, and now I see this 2 times z to the negative 2 power. Now remember, the power only applies to the base right before it. So this 2 stays on top of the fraction. That 2 stays on top. And then on the bottom of the fraction, I'll put z to the positive 2 power. Okay, let's address this one. This 2 times z to the negative 1 power, the 2 stays on top of the fraction, and the z to the negative 1 drops to the bottom of the fraction and becomes a z to the positive 1. And now I have a plus sign, right? And now I see 2 times z to the negative 1 power, and this is in parentheses, right? So the negative 1 power applies to the 2 and the z. That's why I'm going to put 2 and z at the bottom of this fraction with that 1 on top, right? Took the reciprocal of 2z. The reciprocal of 2z is 1 over 2z. Great. And so this is the first step that you need to take for this problem 18. Now that you've rewritten everything like this, we can find the LCD of the 4 denominators and multiply the top and bottom of this fraction by the LCD. This is the easy method. Okay, this is the easiest way to get it done. Okay, and so I look at z, z squared, z, and 2z, and I come to the conclusion that 2z squared is the LCD. And so I multiply 2z squared on to the top stuff and the bottom stuff of this rational expression. And so now I'm going to distribute into all the terms, right? And I'm going to write my result. What's great about multiplying by the LCD is it will clear the fractions on the top and clear the fractions on the bottom here. And so 2z squared times 1 divided by z is 2z. And 2z squared times 2 is 4z squared. Divided by z squared, well, it's just a plus 4, right? The z squared cancels the z squared of the denominator. The z squared of this factor cancels the z squared of this denominator, and we just get 2 times 2, which is 4. Looking at the bottom, 2 times z squared is multiplied by 2 and then divided by z, and so I get a 4z. And lastly, 2z squared is multiplied with 1 and divided by 2z, and so I get just a plus z. Now I look at the numerator and I say, can I factor out a GCF? And the answer is yes. The GCF is 2, and I'm left with z plus 2 in that numerator. Right? So this numerator is 2z plus 4. Well, I had a GCF of 2. I'm left with z plus 2. And then 4z plus 1z is 5z. That's my final result. It doesn't simplify any further. That was problem 18. Okay, let's move on to problem 19. It says perform the indicated operation and simplify if possible. Assume any factors you cancel are not 0. Same instructions that we've been seeing. P to the negative 1 power minus 9 divided by 9 plus p to the negative 1 power. And so I'm going to rewrite this as 1 over p, right? P to the negative 1 power is rewritten as 1 over p to the positive 1 power. And then that's minus 9. And I'll write 9 over 1, right? So I'll turn this integer 9 into 9 over 1. That way I see the fractions easily. And then I move to the bottom, and I see this 9. I'll turn it into 9 divided by 1, plus, and that p to the negative 1 power, I write as 1 over p. Great. So I've rewritten this expression like this. So it looks like a complex rational expression. Next, let's use the easy method. We're going to multiply the top and the bottom by the LCD of P1, 1, and P. The LCD is P. Okay? Now, I'm going to distribute the LCD into all of the terms on top and bottom. And I'll write my result. Because P times 1 is P, divided by P is 1, right? So you think P here canceled this P in the denominator. Now I get a minus, and P is multiplied with this 9. So I get a 9P. And looking at my denominator, P is multiplied with 9. So I get a 9P. That's 9P over 1. It simplifies to just 9P. And then I get a plus. Well, this is P times 1, which is P, divided by P. P divided by P is just 1. And this is my final answer. 1 minus 9P divided by 9P plus 1. 1 minus 9P divided by 9P plus 1. Problem 20. Solve the equation. Okay, 6 over x plus 3 over 2x equals 10x. We're going to solve it algebraically. Now, the strategy for solving a rational equation is to multiply the entire equation by the LCD to clear the denominators, right? And this is the first equation that we're solving, right? Everything else before problem number 20 said to simplify the rational expressions. Now our goal is to solve the rational equations. And so what we're going to do is take the entire equation that we were given and multiply by the LCD. And the LCD is 2x in this case, right? So I'm multiplying everything by 2x. And so that distributes into the first, second, and third terms of this equation. And I'm going to rewrite the equation on the right. By the way, x will cancel x, right? This is the factor of the denominator. It cancels that x. 2 is multiplied by 6 to get 12. Now I have a plus sign of the equation. The equation has a plus sign, so I put that plus sign. And now this 2x will cancel this 2x, right? The 2x factor that I'm multiplying in cancels the 2x factor of the denominator, and I get a 3. And that's equal to, now, 2x times 10. Well, 2x times 10 is 20x, right? Just really quickly, 2 times 10 is 20, but I still had that x that I was multiplying in as well. And so I get a resulting equation, and this is a linear equation. I've cleared the fractions because I multiplied by the LCD. No more fractions. This is the result, and it's a linear equation that I can clean up and solve. Like 12 plus 3 is 15. Okay, that equals 20x. Now I'm going to divide 20 from right to left, and I find out that x is equal to 15 over 20, which reduces to 3 over 4, 3/4. Great. Now we always want to check for extraneous solutions. What are the values of the denominator that would cause it to be 0? Well, that's if x was equal to 0 itself, right? So the extraneous solution would have been x is 0. But that's not what I got from my solution, so it's safe. It's not an imposter. I can keep it. Great. So reporting my answer for fun, x equals 3/4. No extraneous solutions. Good times. Problem number 21. Okay, we have an equation. It says 1 over x minus 4 equals 2 over x plus 1. This is a rational equation. And so we're going to take it and multiply it by the LCD. And the LCD of this equation is x minus 4 times x plus 1. The LCD is literally just the factors of the denominators that we see multiplied together. And I'm going to apply the LCD. I'm going to multiply it into the equation, all the terms. And I'll write the result. And by the way, this x minus 4 denominator will cancel this x minus 4 denominator, or, this factor cancels that factor. 1 is just multiplied with x plus 1. So I get x plus 1. Now I see an equal sign, so I write the equal sign. Great. Now this x plus 1 factor will cancel this x plus 1 factor, so 2 is multiplied with x minus 4. Great. So I have just cleared the denominators of this equation. There are no more denominators. This is the result. It's a linear equation that I can solve for x. In fact, I'm going to distribute this 2 into both those terms. So I'll write x plus 1 equals 2x minus 8. Now I'm going to move all my terms with x to one side of the equation and all my constant terms to the other side of the equation, like that. And so I discover that x is equal to 9. This is my result. X equals 9. Okay, so when we multiply by the LCD into a rational equation, we get an equation that is a linear equation, right? We cleared the fractions, linear equation, and then we just apply strategies for solving a linear equation that we've learned in the past. Great. Problem number 22, solve the following equation for W. And we see here that W is in the denominator of this fraction right here. And so we're going to do the same strategy. We're going to multiply the entire equation by the LCD, which is 3W. Right? I see this denominator of 3, same denominator of 3, and this denominator of W, the LCD is 3W. Multiply into all of the fractions. And let's write the result. So this 3 cancels that 3. 7 is multiplied with W, so I get a 7W. Now I see a plus sign, so I write the plus sign. Look, plus sign. I'm writing a plus sign. Now, distributing 3W into 1/3. Well, this 3 cancels that 3. 1 is multiplied with W. 1 times W, W. And that's equal to, well, this W factor that I'm multiplying in cancels this denominator of W, right? They cancel each other. And so negative 4 is multiplied with 3 to make negative 12. So when I multiply in the LCD, it clears all the fractions. I now have an equation with no fractions. It's a linear equation. And let's get out your strategies for solving a linear equation. Combine like terms, like 7W plus 1W is 8W. So we can combine like terms. And then we notice, hey, if I divide by 8, that gets W alone. So W equals negative 12/8, which that's a fraction which reduces, because 12 and 8 are divisible by 4. And so we get a negative 3/2. W equals negative 3/2. We always check for extraneous solutions. In this case, the extraneous solution would have been 0 for this W. So W is not allowed to equal 0. But we didn't find that as our solution, right? None of our solutions were W equals 0, so we're safe. Great. Moving on, problem 23. Solve this equation for x. All right. So looking at this equation, let's clear the fractions. We don't want to have fractions, so we multiply everything by the LCD. And I look at my denominators of 2 and 3, and I say the LCD of 2 and 3 is 6. And I multiply 6 into all 3 terms of this equation. And, if I took 6 and I divided it by 2, I'd get 3. And I multiply that with x. That's why I'm writing 3x. And now I write the equal sign of the equation, right? The equal sign is there, so I write it there. 6 divided by 3 is 2. Multiply that with x, and I get 2x. Okay, and now I have the plus sign in the equation, so I write it. And lastly, 6 times 2, that's 12. I have rewritten this equation that had fractions as an equation that does not have fractions by multiplying the LCD. Next, I'm going to solve the resulting linear equation. I'm going to subtract 2x so that all my terms with x go to the same side. And 3x minus 2x is 1x, and that equals 12. I've solved for x. I'm done. X equals 12. Great. No extraneous solutions because there's no variable in the denominator in the first place, so I don't have to worry about that. And let's go ahead and solve this last problem, problem number 24. It says 4x minus 3 over 3 minus 4 minus 4x over 5 equals 4 over 3. And in this case, nice and simple, I've got an LCD of 15, right? Because I look at the denominators, 3, 5, 3, the LCD is 15. This will clear the denominators if I multiply it into everything. Okay? And so rewriting this, 15 divided by 3 is 5. So I multiply 5 by this. 5 times 4x minus 3 is how I start. Now I see this minus sign, so I write the minus sign. And now 15 divided by 5 is 3, which I'll multiply with 4 minus 4x. And that's equal to, well, 15 divided by 3 is 5, and I multiply that with 4. 5 times 4. I'll write it explicitly, 5 times 4. Great. Now let's clean up this resulting equation. So we'll distribute, like 5 times 4x is 20x. 5 times negative 3 is negative 15. Negative 3 times 4 is negative 12. And negative 3 times negative 4x is positive 12x. And that equals 5 times 4, which is 20. All right. Let's combine like terms, like 20x plus 12x, that's 32x, right? So I get a 32x. And then negative 15 minus 12 is a negative 27. And that equals 20 still. And now 2 steps to solve for x. Add 27, divide by 32. I'm going to add 27 from left to right. Okay, I get 32x equals 47. And now I'm going to divide by 32 on both sides. And I find out that x equals 47 over 32. Looks like that's not a reducible fraction. I'm pretty sure 47 is a prime number. So I put my final answer as 47 divided by 32. And we have now completed all of the Chapter 7 review, all 24 problems. Okay? Now you would have had very similar problems to the problems that I have just demonstrated. Best wishes to you as you prepare for the Chapter 7 test.